Hi there. Well, once we have covered the basic vector operations, let's take note of these eight basic operation properties of vectors. In the first one, if you add vector A and vector B, it is the same that if you add vector B plus vector A. Uh, some of these properties are known to you because most of these are similar to the arithmetic properties of numbers and basic operations. So if you have vector A and you add this vector to B plus C, it is the same that if you add A and B and then you add vector C. If you add vector A plus 0, you will get back uh, vector A. If you add a vector A plus minus vector A, you will get back a 0 because this cancel each other. You multiply a sum of vectors by a scalar. In this case, C is a constant value. It is the same that if you calculate C times vector A plus C times vector B. If you have a constant value C plus D times a vector A, it will be the same if you multiply C times vector A plus D times vector A. If you have in this case a couple of constants C and D times vector A, it is the same that if you calculate C times D times vector A. If you multiply the vector for any identity, you will get back the vector itself. So with these 8 properties, we finished the first module. The last topic for today is the calculation of the unit vector. So let's start with this unit vector, or in Spanish, this is vector unitario. The unit vector length equals always 1 if, uh, let's say, for example, vector A is different than 0. So the general formula for this unit vector will be 1 uh, over the length of the vector times the vector. So in a more general way, we will have that the vector itself divided by the modulus or the length or the vector. Okay, let's do an example. Let's work with a vector A, and this vector A, let's say that is equal to 2i minus j minus 2 times k. And we want to find the unit vector for this vectorial notation. So the first thing that we need to calculate is the length. So let's start with the length, and we know that the length for A for this is going to be equal to 2 to the square, which is the first component, plus minus 1 square plus minus 2 square, and calculate the square root of that. Okay, if we do the operations inside this square root, we will come up with this is the square root of 9, which equals 3. So the length for vector A equals 3. It is the same that if you have this vector in this standard basis notation or the component notation, which is 2 comma minus 1 comma minus 2. So it is the same, just I'm changing the notation. This is going to be equal but I need to use both because we are going to be working with both notations. So we said that the unit vector equals 1 over the length times the vector. So this is 1/3 times the vector, which is 2i minus j minus 2k. And this is equal to 2/3 I minus 1/3 j minus 2/3 k. And if you see this amount of this fractional amount of this quantity equals 1 for each one of these vector components. So this is the unit vector for this vector right here. And please take note of this formula because you are going to use it, especially when you work with directional derivatives and partial derivatives. You will need to apply the unit vector to your calculation, the calculation of forces and motion problems. Okay, so if you have any questions or you are in doubt, please let me know. You can post a comment, send a text message, or send an email. I will be available to answer your questions. With this lecture, we finish the first module of multivariable calculus. Bye.